All right. I'm doing this really, really late, so I'm not expecting people to be asking questions. But um, if you do have questions between now and the exam, just email me and I'll try my best to get back to you. But I want to get this out so people could watch it and kind of have time with it, as opposed to doing it the night before and that being it. Um, so I kind of want to go over exactly what I'm expecting for all three of these things. Right, so trig functions, so given a right triangle, give me the trig ratio of sine, cosine, tangent, secant, cosecant, or cotangent. And then using trig identities, prove that a left-hand side is equal to the right-hand side. And then graphing trig functions, so sine, cosine, secant, and cosecant. I want to, before I actually do examples, so I've got the review, which can be found in On Campus, which is this. And then the practice test, which can also be found in On Campus, which is this. Okay. I've got all of those things. I'm going to do as much as I can. But I want to go over the actual like notes that we did in class in order to get to those places. Okay. It's a brief version of that, but I'm hoping that it can at least trigger what your thoughts were when we were doing this in class and when it was really, really current. All right. So what's going to happen is I want to go through these notes, and then I'm going to go through a bunch of questions. And if people are here, obviously ask questions, but then it'll just be up after this is done. Okay. So three things being covered on this exam: trig functions given a right triangle. Okay, this is just SOHCAHTOA. This is stuff that you guys did as juniors, possibly as sophomores. Then trig identities. So I'm going to go through how those trig identities actually come up. And then I will solve some, and then graphing trig functions, right? So graphing sine, cosine, secant, and cosecant. So trig functions. This, if we know this stuff right in the middle of your screen, you're able to get every single thing I'm about to go over. So the better you understand a unit circle, the better your understanding is going to be of all of this stuff moving forward. Okay, so remember two things. First of all, sine. We're defining sine of an angle of rotation. That's going to give us the y coordinate on a unit circle. Okay, so a unit circle is a circle whose radius is 1. Okay, and when you take sine of an angle, you're going to get just the y coordinate, right? So sine of an angle, that angle points to the edge of a circle. The edge of a circle has an ordered pair xy. Sine gives you the y coordinate. So all of that stuff is going to be green this entire time. Cosine gives the x coordinate. All right, it's the same thing. So cosine of an angle, cosine of some angle points to the outer edge of a circle, which has a point xy. Cosine points to the x point. All right, and then tangent is the ratio between the two. All right, and then there's the reciprocals. So cosecant is 1 over y. Secant is 1 over x, and then cotangent is x over y, as opposed to y over x, x and y. All right. This all has to do with right triangles. Okay, so we can use the Pythagorean theorem, which says that the x, right, the horizontal distance, which is going to be in blue, right, that's the cosine, and the y, the vertical distance, which is going to be in green. So those two, the sum of those two things squared is going to equal to 1, because that's the hypotenuse of a unit circle. Okay. So we have these functions. Those are just definitions. Okay. From these definitions, we get the reciprocal functions. Okay. So if you can kind of see both, I know it's going to be a little bit hard. Oh, all right. Sine gives you y, so, and cosecant gives you 1 over y. So focusing on cosecant, Cosecant is 1 over y, so that's 1 over sine. And then sine is 1 over cosecant. Okay. Secant is 1 over x. We can substitute that for cosine, so secant is 1 over cosine. And then tangent is y over x, so we have sine over cosine. And then from that same logic, we're going to get the others. Okay. So sine is 1 over cosecant, cosecant is 1 over secant, cotangent is cosine over sine. And then we have these two others. Cotangent is 1 over tangent, and tangent is 1 over cotangent. Okay. These should be kind of self-explanatory. They're really just definitions, and then we are using substitution with those definitions. That's it. Okay, so those are reciprocal identities. And then from the Pythagorean theorem, we're going to get these Pythagorean identities. So up above, we said that x squared plus y squared is equal to 1 on a right triangle within a unit circle. Okay, so again, if we're just using substitution, we can substitute x for cosine. So if we do that, instead of x squared, we have cosine squared. And then instead of y squared, we have sine squared. And then 1 squared is just 1. So we get this identity. We get cosine squared plus sine squared is equal to 1. And this, if we know this, we can get the other two. Okay, so if we divide both sides by cosine squared, all right, we get this. And then if you kind of just simplify all of that, right, cosine squared divided by cosine squared, that's just 1. Sine squared divided by cosine squared, that's the same thing as tangent squared. And then 1 over cosine squared, that's just secant squared. Okay, so that's the second identity. And all we're doing for this identity is we're just dividing everything by cosine squared. Okay, if we do a similar thing, if we, instead of dividing by cosine squared, we divide by sine squared, we'd get cosine squared divided by sine squared plus sine squared divided by sine squared is equal to 1 divided by sine squared, right? So this left-hand thing, this cosine squared divided by sine squared, that's cotangent squared. Sine squared divided by itself, that's just equal to 1. And then 1 divided by sine squared, that's cosecant squared. Okay, so really all we need to know is this type identity, and those other two follow, so long as you know exactly what to do. Okay, if that scares you or makes you feel uncomfortable or whatever, you can still just memorize it, but that's instead of having to memorize so much, right, because we still have to have this stuff, you can just memorize that one thing and then the rest follow. All right, so those are the trig functions. These are the trig identities. And then the last thing we're going to have to do on this is to graph sine and cosine. So from these definitions, we can get we can graph these trig functions' behavior. All right, so we're going to worry about sine and cosine, and then cosecant and secant. Okay, and again, like I said up above, if we understand this unit circle, the better we understand that, the more this stuff is going to make sense. Okay, so if you're still unsure of the unit circle, I would encourage you to go back and look at one. Go back and look at your notes where we explained it in class and kind of ran over it. This is just a quick, brief overview of those notes. All right. So again, we're going to have cosine in blue. We're going to have sine in green. Cosine of our starting angle is 0. That's going to give us the x value at that point. That's going to be 1, which is why it starts up top. As we increase the angle, right, so now we're here, this x value is decreasing, right? It's getting closer to the center. All right, so our x value is going to decrease. Then we're going to get to pi over 2. It's going to be 0. That's this point right here. It's going to get to, it's going to go past pi over 2. So it's going to be in the negative direction. It's going to get to pi, so it's going to be -1, which is this point right here. It's going to go back up to 0, up until 3 pi over 2, which again, x will be 0. And then it's going to go back up to the maximum at 1. Okay, similarly for sine, okay, sine of our starting angle 0 gives us 0, so we're starting down below. We are going to increase our y value up until pi over 2. Then we go back down to 0 at pi, down to -1 at 3 pi over 2, and then back up to 0 at 2 pi. Okay, so again, if you're just tracking the x and y values around the unit circle, as you go from 0 to 2 pi, you're going to get the graphs of sine and cosine. Okay, and I drew these red lines so we understood that each of these like major critical points, right? So the zeros, the maximums, and the minimums, they all happen in quarters amounts of time, right? So quarter the period. And they're always going to happen like that. It's always going to be really, really predictable. Okay, so knowing that is also really helpful, right? That should make sense too, because every pi over 2, right? So pi over 2, pi over 2, pi over 2, and pi over 2, we're going to get one of those critical values. So we're going to get 1, 0, -1, or -1 or 0 again. Okay, so that's how we're going to graph sine and cosine. That's the general, like that's the parent functions. Okay, in general, when we graph stuff that looks like this, okay, the thing we're multiplying the sine or cosine by, that's called our amplitude. The thing we're adding to the outside, that's our vertical shift, right? That's from last semester, that's our center line. And then from the center line, we add the amplitude and we subtract the amplitude, and that tells us how far we go up and how far we go down. Our starting angle is when we set everything inside parentheses equal to 0. And then our ending angle is when we set everything in parentheses equal to 2 pi. Okay, which again should make sense if we're just looking at our unit circle, right? Our starting angle is 0, our ending angle is 2 pi, so that tells us what's happening inside that angle. And then the period, how long that takes, is just the end minus the start. And then like I said above, each critical point is the same distance away, so to find those we can just use the averages, which I'll show you in a little bit. Okay, so that's graphing sine and cosine. We still need to graph cosecant and secant though. So for a cosecant of bx minus c plus d and a secant of bx minus c plus d, we're going to graph them in this general idea, right? So for cosecant, we're essentially just going to graph sine, and then we're going to draw up from minimums, or sorry, down from minimums and up from maximums. And we're going to get asymptotes when those functions like sine and cosine would be 0. Okay. And then for graphing secant, we would just draw the cosine graph, and then again draw up from the maximums and draw it down from the minimums. And we're going to get asymptotes at pi over 2 and 3 pi over 2. And then for cosecant, it's going to be 0 and pi. Okay. So our graphs are going to look like this, right? So in green, if we got a cosecant graph, the first thing we would do is we would draw this dotted green line, which is the sine graph, right? So we would just ignore the cosecant for a second, pretend it's sine. We would get this dotted green line, and then from our maximums we draw up, and then from our minimums we draw down. And then every time we hit a 0, that's our asymptote. Same thing for secant. Okay, instead of secant, we would just ignore that. We would graph the cosine version of the graph that's dotted in blue, and then again draw up from the maximum, draw it down from the minimum, and then again up from the maximum. And like I said, every time that cosine were to hit the center line, we would get an asymptote. Okay, so if we know how to graph sine and cosine, we know how to graph secant and cosecant. So again, so to graph these functions, graph the originals, so graph cosine and sine, then draw up from the maximums and draw it down from the minimums while hugging those asymptotes. Okay, so that's like a really, really quick overview of all this stuff that's being covered. Okay, It's not a whole lot if you really just understand that unit circle, okay, and what sine and cosine are actually doing. But again, if you're confused about something, go back to these notes, which you should already have, and try and understand it. Okay, so now what I want to do, I want to go through the practice test first, and then I'll go over a couple more examples on this review. So I'm going to scroll down. I'm going to start here. Okay. So when we are verifying each identity, we're going to choose, or we're going to simplify the left-hand side, and we're going to simplify the right-hand side. And then we're going to make sure that they are actually equal. Okay. And we're going to do that using those identities, and in general, just like working with fractions and being able to divide by fractions, add fractions, and all that stuff. Okay. So number one, I'm going to take this left-hand side. I'm going to decompose this fraction into cosine over 1 times 1 over cotangent squared. And then I can just use definitions, use those identities to kind of replace cosine and cotangent. So cosine in the numerator, that's equal to 1 over secant in the denominator. And then cotangent in the denominator, 1 over cotangent, is equal to tangent in the numerator. Right, so that's equal to that. That's equal to this. When we multiply those two things together, we would get tangent squared over secant, which is exactly what we're trying to make sure it's equal to. Okay, and again, I want to warn you, okay, watching me do this is very, very different than you being able to do it on your own. Okay, so this is just an idea of how to do these. This is not like, you know, on the exam, you're just going to be given a piece of paper and you're going to have to prove it to me. Okay, so just be wary of that. On number two, there's two different ways to go about it. I think what most people would choose is to choose with the left. That's not necessarily the easiest, but that's the one I'm going to do because I think that's what most people would do. So I'm going to think of cosine as cosine over 1 and tangent as sine over cosine. In order to add these two fractions together, we would need a common denominator. So what we would do is we would multiply this left-hand fraction by cosine over cosine, and this right-hand fraction by 1 over 1. And when we do that, we'd get cosine squared over cosine plus sine over cosine. And then now, because they have a common denominator, all we have to do is add their numerators together and put them over the same denominator, right? And then when we get here, this is what we were trying to prove. So we're done. For number three, so 1 and 2 are just going to be using the reciprocal identities, the ones in that big box that were up above. And then number 3 is going to use one of the Pythag identities. All right, so what I'm going to do is, again, I'm going to decompose this left-hand side into cosecant squared over 1 times 1 over secant squared. And this right-hand side, we need to think about a little bit. Okay, so we have this identity that says that cotangent squared plus 1 is equal to cosecant squared. And we can rearrange this. If we subtract 1 on both sides, we would get cotangent squared is equal to cosecant squared minus 1, which is exactly what we have on the right-hand side. So we could replace this cosecant squared minus 1 with just cotangent squared. Okay, so we're simplifying the right-hand side. We didn't move anything around. We're just simplifying it. Okay, and then again, we're just going to use those reciprocal identities to see what cosecant and 1 over secant are. Okay, so cosecant squared, that's the same as 1 over sine squared. And 1 over secant squared is the same as cosine squared over 1. When we multiply these two things together, we get cosine squared over sine squared, which is just cotangent squared. And we see that this left-hand side is equal to that right-hand side. So then we proved this equality, and we're done. For all of these, there's different ways to do these. So just because I did it this way doesn't mean you wouldn't be able to get a right answer doing it another way. Okay. Some ways require a lot more steps, but you still should be able to get the identity. Right, so that's 1 through 3. Number 4. Shift this over just a little bit. Okay, number 4. We need to do a whole bunch of work before we can do anything. Okay, so we have to identify the vertical shift, right? So D, in this case, that's just -2. We have to get the amplitude, which in this case is just 1/2. We have to get a start point. And that's when we set our entire angle equal to 0. Oops. And then we solve for theta. So we add pi over 3 to both sides, and then multiply by 1/2. Do the same thing for the end, except now we're going to set this equal to 2 pi. And when we solve this, we have to add pi over 3. And then multiply by 1/2. And then our period is just the difference between the start and the end. So that's just 7 pi over 6 minus pi over 6, which is 6 pi over 6. Okay, so we have a start, we have an end, we have a period, vertical shift, and amplitude. Okay, so now we just have to graph it. Okay, so we make our t. This center line, right? That's the vertical shift. So this is -2. We go up 1/2. We go up the amplitude. So this is going to be -1.5. And we go down our amplitude. So that's going to be -2.5. Okay, then we draw a sine graph, or sorry, a cosine graph. Right, cosine. So we start up top, go down to 0, down to the minimum, and then back up to a maximum. And our job is to label these 5 points, 2 of which we already know, right? The start, that's just pi over 6, and then how high that is. And then the end, this is 7 pi over 6, and how high that is. Okay, in order to get each of these other 3 points, what I'm going to do is I'm going to find the midpoints between them, so I'm going to average the x values. All right, so I'm going to average pi over 6 and 7 pi over 6. I can also just think about averaging the numerators, right? So 1 pi over 6 and 7 pi, so 1 and 7. So this is the same as 7 plus 1 divided by 2 times pi over 6. Right, so this is 4 pi over 6, comma, negative 2.5. And I can do the same thing here, except I'm averaging 4 and 7. Right, so 4 plus 7, that's 11, divided by 2, that's 11 halves. 11 halves divided by 2 times 6, that's 11 twelfths. And then that's at negative 2. And then this is the average of 1 and 4. Which is going to be 5 pi over 12. And then this would be all the work that you show, right? So you find the vertical shift, you find the amplitude, the start, the end, and the period, and then you graph it, right? So the correct shape, that's worth points, and then each of these points, each of these is worth a point. For secant, you do kind of the same thing, but then your last step, there's one more step at the end. Okay, so we have secant, so we're going to look at instead 2 cosine of 2 theta minus 3 pi over 4 minus 2. Okay, so we're going to graph this, and then at the very end, we're going to actually graph the secant portion. Okay, so our amplitude here is 2. Our vertical shift is negative 2. Our start, we take our angle and set it equal to 0. For the end, we take our angle and set it equal to 2 pi. If this confuses you, think about it for a second. You're adding, oops, that's not right. Oh, I messed something up. These should all be pluses. So that changes some things, but everything else is the same. So we get 2 theta is equal to negative 3 pi over 4. So theta is negative 3 pi over 8. And in this case, we get 2 theta is equal to 5 pi over 4. That's what I was thinking before. Right, and again, if this doesn't make sense, think about it. Think about subtracting 3 pi over 4 from 2 pi. Right, you have to get a common denominator, and then you can subtract the numerators. Okay, we have a start, we have an end. The period is just the end minus the start. So that's 8 pi over 8. And then we can start to graph. Okay, so we want to graph this. So we're doing with cosine. So we're going to have the same graph we had before. We need to label these points. Again, we have two of them. So at this point, that's negative 3 pi over 8. I'm sorry, I should do the vertical shift and all that. This is negative 2. Negative 2 plus 2 is 0. Negative 2 minus 2 is negative 4. So this point right here, that is negative 3 pi over 8, comma 0. And this is 5 pi over 8, comma 0. And then to find this middle point, we're going to average 5 and negative 3. So 5 plus negative 3, that's 2. 2 divided by 2 is just 1, so this is just pi over 8. And this is the average between those two. So 5 plus 1, that's 6. 6 divided by 2 is 3, so this is 3 pi over 8. And then this is the average between negative 3 and positive 1. So negative 3 plus 1, it's negative 2. Negative 2 divided by 2 is just negative 1. So this is negative pi over 8, comma negative 2. Okay, now this is graphing cosine. Our problem is asking us to graph secant. Okay, so what we need to do is we have to draw our asymptotes. So that's where our graph crosses our center line. And then again, we draw up from the maximums. And we draw down from our minimums. And then that would be our graph. So the stuff in red is our actual secant graph. Everything else is just there to help us. Right, so all of these points are still the same. Right, so this right point is the same, this left point is the same, this middle point is the same. And then these points, those tell us the asymptotes. So the asymptotes in those cases are 3 pi over 8 and negative 3 pi over 8. Right. And then these last two should be decently easy. Right, so secant, that is hypotenuse over adjacent. So in this case, the hypotenuse is 15, the adjacent side is 12, and then we're really done. So this is 5 over 4. This next one is a little bit different. So cotangent is adjacent over opposite. We have the adjacent side. We need the opposite side. So what we need to do is we need to set up the Pythagorean theorem. So 18 squared is equal to 12 squared plus the opposite squared. 18 squared is 324. 12 squared is 144. If we subtract those, we get 180. And then we need to take the square root. So the opposite is equal to the square root of 180, which we need to simplify. So we can rewrite this as the square root of 9 times the square root of 20, which is square root of 9 is 3. We can split up the square root of 20 as the square root of 4 times the square root of 5. Square root of 4 is 2, so 3 times 2 is 6. So we get 6 rad 5. So this opposite side is 6 rad 5. So then we just plug everything in. So we get 12 over 6 rad 5. 12 divided by 6, that's 2. So we get 2 over rad 5. And then we need to rationalize. So we get 2 rad 5 over 5. And then that's our final answer. So that one's a little bit more involved. But we're just using the Pythagorean theorem and then what cotangent is. And then rationalizing. Okay, so that's the entire test. Again, just knowing a couple of things really goes a long way on this test. It's not a huge breadth of knowledge. It's just putting things together in different ways. All right. So I want to go over a couple more examples of the identities just so people have a good idea as soon as I can scroll to the left. Okay. So let's just do number 19. All right. All right, number 19. So again, I like to split up fractions as much as I can. So I'm going to make this 1 over tangent squared over 1 times 1 over sine. Okay, 1 plus tangent squared from the Pythagorean identities. That's equal to secant squared. So we can rewrite this as secant squared divided by 1 times 1 over sine. Well, secant squared is 1 over cosine squared. 1 over sine is cosecant. Multiplying those two things together, we get cosecant over cosine squared. And that's exactly what we were trying to find. Number 18, I'm going to write cotangent as cosine over sine, secant as 1 over cosine, and then I know 1 plus cotangent is cosecant squared, and that's from a trig identity. That's from the Pythagorean identity. So 1 plus cotangent squared is equal to cosecant squared. Hi, Benny. So when we do this, when we multiply these two fractions, these cosines cancel, and this should be a squared, and this should be squared. So we're left with 1 over sine squared. 1 over sine squared is cosecant squared. So we prove that this left-hand side is equal to that right-hand side. Pre-calc review. Yep. Number 17, I'm going to write cosecant squared as 1 over sine squared, and secant squared is 1 over cosine squared. And I'm just going to try and add these two fractions together and see what happens. In order to add these two things together, we need a common denominator. So we need to multiply the right by sine squared over sine squared, and the left by cosine squared over cosine squared. When we do this, we get cosine squared over cosine squared sine squared plus sine squared over cosine squared sine squared. You probably did well on this test. This is one of my favorite things because this is, people can get into this. It's just a puzzle. Okay. And it has to do with fractions, which people are not good at. So now that we have a common denominator here, we can just add the numerators. So we get cosine squared plus sine squared over cosine squared sine squared. This numerator, cosine squared plus sine squared, that's just equal to 1. And then I can split up both these fractions. And we're looking for cosine in the bottom, so that stays the same. And 1 over sine squared, that's just cosecant squared. So we get cosecant squared over cosine squared. And then that's the right-hand side. So we proved that the left-hand side is equal to the right-hand side. Number 16 is the exact same. It's just one step less than the one we just did. Right, so we got 1 over cosine squared here. 1 over cosine squared times sine squared. Well, that's what we're trying to prove right here. Number 15 is a little bit harder. Okay. So from our identities, we know that 1 plus tangent squared is equal to secant squared. So if we subtract tangent, well, actually, if we subtract secant from both sides and subtract 1 from both sides, so I'm going to do this in 2 steps. So we get 1 plus tangent squared minus secant squared is equal to 0. And then if we subtract 1, we get tan squared minus secant squared is equal to negative 1. Okay, so this numerator is just equal to negative 1. So we get that this this right-hand side, this whole right-hand side is just equal to negative sign. On the left-hand side, we get negative 1 over sine squared. Oh, that's not right. No, yeah, that's right. Nope. Let's try it a different way then. Okay, on the left-hand side, we get 1 over sine squared times sine. Okay, so one of these cancels one of these, so we're left with negative 1 over sine. Which is exactly what we got on the right-hand side, right? So this numerator, that's equal to negative 1. And then we have sine in the denominator. These two things are equal, so we're done. Okay, I'll do like 1 or 2 more. I'll do one of the one of these. Okay, so let's do number 9. So sine squared, that's just sine squared. Secant squared, that's 1 over cosine squared. Multiplying these two things together, we get sine squared over cosine squared, which is tangent squared, which is 1 over cotangent squared. So this left-hand side is equal to that right-hand side, and then we're done. And then number 8 is similar. We get 1 over cosine squared times cosine over 1. So cosine over cosine squared. One of those cancels one of those, and we're just left with 1 over cosine. So our left-hand side equals our right-hand side, and then we're done. I saw an interesting one. Yeah, let's do number 10. So this is a little bit different. Not difficult, just different. So if we distribute this, we get cosine squared, cosecant squared, minus cosine squared. This is cosine squared times 1 over sine squared, minus cosine squared over 1. This whole thing is cotangent squared. I'm going to leave this. I'm going to try and subtract those two fractions. So we get cosine squared over sine squared minus sine squared cosine squared over cosine squared. That should be a sine squared. And then we get this, which okay. If we factor now, so if we factor a cosine squared out of both, we get 1 minus sine squared over sine squared. This, if we think about sine squared plus cosine squared is equal to 1, then 1 minus sine squared is equal to cosine squared. So we get cosine squared over sine squared. This is cotangent. And then this is 1 over secant. Multiplying those two things together, we get cotangent over secant. A little bit different. Recognizing this is the hard part. I don't think I'll go this hard on the exam, but it's a good example. All right, that's a lot of examples. I don't want to do all of these because I feel like we did a lot of them in class too, so I'm going to leave it here. Again, if you have questions between now and the exam, just email me and I'll try and get back to you. All right, so I'm going to finish here, and I will see you during the exam.